Welcome back, Algebra Express. We are at Marecek 7.2. So I believe this is the last chapter in Marecek. And this is over adding and subtracting rational expressions. So last time we talked about multiplying and dividing rational expressions, which are like fractions. And so we have things that look like fractions. And we also have rational expressions that look like polynomials over polynomials. And I talked briefly about this, about how to add and subtract fractions. But you might notice on this first page, and they start out with expressions with like denominators. So if we look in the bottom and we look in the denominator, you might notice they keep the denominator the same here. So if we do something like 11/15 minus 8/15, the way that we add and subtract fractions is we keep the denominator and we do the 11 minus 8 on top. This is going to give me something like 3/15. And when I get this result, then I have to look at this and I have to see if I can simplify this at all. So when we simplify these things, we're factoring these numbers. So we're going to have to factor the polynomials after we add and subtract them. We can divide 3 by 3, that gives me 1. We can divide 15 by 3, that's going to give me 5, and this is going to be 1/5. So this page is all about like denominators. They kind of jump on the next page, and I don't believe they give you an example, but last time I did something like a half plus a third. So if they are not the same denominator, we have to do some tricks to make them the same denominator. And so we multiply by like a big fancy 1. Between 2 and 3, we find the least common multiple of 6. So I got to multiply this by 3, got to multiply this by 2. This becomes something like 3/6 plus 2/6 gives me 5/6, which is already fully reduced. So on the next page, we will be talking about finding the least common multiple between polynomials. Okay. So if I look at this thing, I want to use the same rule. This has the same denominator. This has a denominator of 3x. I can't write this anymore. 3x minus 2. Let's do that again. And on top, I'm looking, I have 3x squared. And so if this was a subtraction sign, I would have to be really careful because there would be some distribution implied in here. I would have to distribute it to everything up top. But this is just an addition sign, so I think I'm just going to go plus 13x minus 10. Okay, so I'm looking at this thing. I did the addition step, combined it over one common denominator. Ooh, I did this problem. Almost. There is one other thing. Like this thing I said, we simplified it. We're going to have to factor this and simplify it. So if we want to factor this thing, you might be able to guess. There's probably a 3x minus 2. And if you want to maybe try to guess and check this, that might be one way. And so if I'm looking here, I know 3x, I know I need an x. And then the last thing is a minus 10. So we're thinking about how to get that with the 2. That'd be by multiplying by 5. And then if you want to check this thing, You can always come back through and distribute it through and see if you get the same thing, right? So we have gone over factoring. I don't want to spend a lot of time on factoring because we've done a few sections over it. But sometimes you can guess and check these. So this one, it worked. But I definitely checked to see it worked. It was a plus 13 in the middle. If anything is different, right? If we have a different sign, if anything is different about this thing, it's not going to factor right. We're going to have to actually factor it, right? It may not be 3x minus 2. It could be 3x plus 2. It could be just a little bit off, right? And it could look very similar. So we definitely have to check these things. They don't always match up, but here they do. And so we see the same thing over itself. So like in the previous section, we see that same factor over itself. That is just a big fancy 1 happening there. And if I have 1, I basically have 1 on the bottom and an x plus 5 on top. Overall, this is just giving me that factor of x plus 5. Okay. So we got the solution x plus 5. So it might seem like a weird thing to do, right? We're doing this and we're adding these 2 things and then we just get this factor x plus 5. But that is the solution. Okay. May not be the solution you're expecting from adding 2 rational expressions, right? But sometimes we get that factor. It's sort of like doing 1.5 and subtracting the half, or adding the half, right? And you get a whole even sort of factor out of it. Okay, so now we want to subtract this. And I try to give you a little bit of a hint with what to do. So let's do the subtraction first. So do the addition and subtraction before you start trying to simplify this thing and factoring it is what I would do. Keep it 4x squared minus 1. On top, I have 2x squared plus 1. And if you put minus 5x plus 4, you're probably going to get this thing wrong. So don't do that. What I have to subtract, and this is what I would do, is I gotta put parentheses around this thing. I'm subtracting this entire term. If you wanted to put parentheses around this thing, I suppose you could. It's not going to make a lot of difference, but it's like we're taking this thing and we're subtracting this thing. And we're keeping the denominator the same. So if we're doing this, I got to do some distribution of that negative sign. Is what I'm trying to get at. If you don't want to do the step of parentheses, that's probably fine. We're going to do minus 5x. You could probably jump to minus 5x and just start negating things in this one, right? Minus 5x minus 4, and we're doing this over 4x squared minus 1. All right, so I think there's some like terms I can combine, probably a specific order I want to put this thing in. So I'm looking at my x squared terms. I have 2x squared. I got a minus 5x. I got a minus 4 and a plus 1 is going to give me minus 3. I got 4x squared minus 1 on the bottom. Okay, so now I have done the subtraction step. I have combined like terms. Now the next thing that I'm looking at here is I need to factor these things and see if I can simplify anything out of this. So after you do addition and subtraction, there might be things that you can factor and simplify out. The bottom, I hope that goes pretty quickly for you. That's a difference of squares. It should look like 2x plus 1 and 2x minus 1. Taking the square root of 4 is 2. Square root of the x squared, it's x. And square root of 1 is 1. So now we're looking at 2x squared minus 5x minus 3. This one might be a bit harder to guess and check, because there is a 2x plus 1, there's a 2x minus 1. But if we multiply these together, I believe we get a minus 6. And we want to add a minus 5, so I believe 2x squared minus 6x plus 1x minus 3. And again, do this by grouping or box method. I'm going to do factors 2x plus 1, x minus. Okay. So this one looks like 2x plus 1, x minus 3. And now I'm looking. Freddy or Jason, I'm going to play the slasher, right? Okay. So x minus 3 over 2x minus 1 is my final thing. Final simplified expression. Okay. So maybe something to point out here now is that currently we are doing expressions, right? And so probably the next step to go, we're just simplifying things, right? Like 11/15 minus 8/15, and I tell you 1/5. I haven't solved anything there. I didn't put any x's in there. There's no x equals a number here. There's no x equals a number here when I solve these two things, right? We are just doing expressions. We are just rewriting these things at this point. So we haven't even, I don't say we haven't even. We haven't set it equal to number and solved for it something yet, right? This isn't equal to anything. So what's coming up is probably that, right? Just trying to look ahead just a little bit. Sometimes the things we do are predictable, I think. If you just think about what you've done so far. Take a step back and a deep breath. Ooh, now we're doing expressions with unlike denominators. Okay, so I talked about this before. This is the half plus the third. We got to find a common denominator. We got to find the least common multiple. The least common multiple of two polynomials is the smallest polynomial that contains both as factors. The least common denominator of two rational expressions is the LCM of the denominators. So if I talk about the LCM or I talk about the LCD is the LCM of the denominators. So it is one and the same thing when we're talking about finding a denominator. So if we find the LCM of 3x squared and 12x. Okay, just to remind you, multiples look like things that are like 3, 6, 9, 12, right? 12, 24, 36, so on. Multiples are going one way, factors are going the other. Just throw that out there. We want to find the least common multiple between 3 and 12 and x squared. Okay. if we want, we could be really thorough. We could say something like 3, and we have an x squared. 12, if we do a prime factorization, we could do 3 times 4. This is 2 and 2. So if I want to write it out as its prime factorization, it looks like 2 squared times 3, and I have an x. So one way we can do this is we have to pull out, what does it say? It has to contain both as a factor. So what that means is I have to pull out the most that I have here. So if I'm looking here, I'm looking at, I need to pull out a 2 squared, and I need to pull out a 3. So you might have already figured out the least common multiple between 3 and 12 is 12. It's probably the simpler way to do it. But I need to pull out the most that it has. It's got to be a multiple of both of these, right? So it's got to contain each of these as a factor. So if I just put an x here, I'm not going to have this thing as a factor. So I need to pull out the most. And I could have said something silly like maybe 2 to the 0. This is what, 3 to the first. So I'm picking the largest exponent it has. It's got to contain both of them. In order for it to contain them, it's got to contain the largest amount of that factor. Same thing here. I want to pick the largest one. This is x to the first power. This is an x squared. Between 1 and 2, I'm picking 2. And you might do this. It's like, where do these first match up? Well, right at 12, right? Okay, so that was a lot of talking to say my least common the least common multiple of these two things is 12x squared. Look, they're in the denominator now. So this is my least common denominator of these two things. So I want to make things 12x squared. So have something that looks like 1 over 12x. I'm going to break it down. But I want to multiply this by something. I want to end up with 12x squared on the bottom. What am I going to multiply this by? So in order to look at this, I want to look in my denominator. That's the thing I'm changing. I'm going to multiply this by, I have a 12 there. The thing I need is I have an x to the first power. How do I go from x to the first to an x squared? I multiply by an x. And if I multiply by an x on the bottom, I also have to do it on top. 1 times x is going to give me an x. And now I have x over 12x squared is another equivalent fraction for this thing. So this is like converting what, 1/2 and multiplying it by 3 top and bottom. And converting 1/2 into 3/6. And now we got to convert our 1/3 to 2/6. So now we're looking here. We're changing the denominator. Look along here. So 3 times what is going to give me 12? That would be 4. My x squared times, I don't need nothing. It's an x squared. I'm done there. What I multiply on bottom, got to also multiply on top. I don't want to change this. I just want to write this to something that's equivalent. Like 2 times 4 is going to give me 8. Now the problem was this thing plus this thing. I got this thing plus this thing. So I have an x over 12x squared. And I'm adding 8 over 12x squared. Now here, it might be really tempting to want to reduce these things. Don't do that. They look weird, they look improper. Kind of like 3, 6, and 2, 6. It's like, I should reduce that. No, not yet. Let's do the operation. Let's keep the same denominator of 12x squared. Let's do x plus 8 on top. And after this, you might think to yourself, is that done? Am I fully simplified? This is like an x plus 8. This is like the x's are by themselves. They're not being added or subtracted with anything. This is like a 12 here. There's nothing I can pull out of here. This is just a factor in itself. That is it. That is fully simplified. Between 1 and 8, there's not a common thing I can pull out, right? That might be one thing to look at. Okay, so that was that problem. Now I got a student activity, so hopefully you're doing this before I do it. Okay. If I want to change, I can think about it as 2 to 5. And I got an x squared and a y. I can think about 3 times 5 would give me 15. I'm just doing the prime factor of these things. And I got an x squared y cubed. So I kind of wrote it with the spacing on purpose. But if I'm looking down and I want to find a common denominator between 10 and 15, I pull down to 2, I pull down to 3, I pull down 1 and 5. So they have a 5 in common. I can kind of figure that thing out and simplify a little bit. Hopefully find the lowest one. Between 2 x's and 2 x's, I definitely got to get an x squared. Between 3 x's and 1 x, I got to pull out the largest one of 3. Always pulling out the largest. We're doing the same if you do the prime factorization. It's just like you do with your variables. You treat them just like primes. Between 1 and 1, we can pull out 1, right? And it's really kind of dumb, right? But I can think about this as no 3's being there. I can write it to a 0 power. There are no 2's being there. And between 0 and 1, guess what? I got to pull out one of them. That's a really complicated way to write 2 times 3 is 6, times 5 is going to give me 30. So you might figure this out another way between 10 and 15. There are probably other ways that you probably already know to find out the least common multiple. But this is one way that will kind of always get you there and always get you the least one. So this is my least common denominator I want to find. I start out with this thing. So if I go 1 over 10x squared, y, multiplying top and bottom by something, I'm going to end up with 30x squared y cubed. X squared y cubed. Multiply this by top and bottom by something we cancel 1. 30 x squared y cubed. Okay, so this should be your setup. In order to get from 10 to 30, I have to multiply by 3. My x squareds are there. My y to the first needs to become a y cubed. So I need to add 2 more y's to that, or a y squared. So again, multiplying common bases is going to add the exponents, right? We did that a while back with exponent rules. Y squared on top. And if I multiply the bottom by this crazy thing, gotta also multiply the top. 1 times that is gonna be, and there's my crazy improper fraction, like my 3/6. Okay, 2 over 15x squared y cubed. I want to go from 15 to 30. In order to do that, I gotta multiply by 2. X squared to x squared is good. Y cubed to y cubed. We are there. If I multiply by bottom on 2, gotta multiply by the top on 2. Gotta do 2 times 2 is going to give me 4. And now let me know what that. This was an addition problem. We got 3y squared over 30x squared y cubed. 4 over that same thing, 30x squared y cubed. And we add these two things together. 3y squared plus 4 is on top over 30x squared y cubed. Up. Without following. Here we go. And so you might be looking at this thing, can I simplify this at all? Between 3 and 4, there's nothing in common I can really pull out. So 4 doesn't even have a y on it. So I think I'm pretty good here. There's nothing I can really pull out. This is going to be the solution of the fully simplified version. Okay. So this is a fully simplified expression. We added the rational expressions together, and we got it fully simplified. Page 2 is complete. Okay. So now they start us off with finding things that are a little more complicated. So in this previous page, what we noticed about these denominators maybe is that I have something like a 12x, 3x squared, 10x squared y, 15x squared y cubed. So those are fairly complicated in themselves, but they are only monomials, right? So the next sort of step we can take is to make these polynomials on the bottom. And so now we have polynomials. You might notice they start by giving you this polynomial in fully factored form. So if it's not given to you factored, maybe like the student activity, you might need to factor these things to find the common factors, to find the least common multiple. So I know on the first page I said don't factor that until afterwards, but that was because it was already set up for subtraction. It was a common denominator already. These are not common denominators. So we want to find a common denominator. We want to find the LCM of x plus 1 squared, and an x minus 1. So if I'm setting these things up, factor it over itself, now I got an x. I got an x. I got an x minus 1. I want to find the least common multiple between all these things. I have one of these here, and I have 2 of them here. Guess how many of them I need? I need the most amount that is there, which is 2. There are no x minus 1s here, but there is one here, so I need an x minus 1. So basically, we're putting one of everything that we see there to the largest power, right? We're going to pick the largest power. So we're looking at this thing. We want to convert it. We found our LCM of these crazy things, and now we want to convert them. So 2 over x over x plus 1 squared. You want to end up with x plus 1 squared and then x minus. Okay. So now I'm looking along here. What do I need to multiply by the top and bottom? I have my x. I have my x plus 1 squared. What is this thing missing? It's missing the x minus 1. So I do it on bottom. I also have to do it on top. Okay. There are a few ways you can do this. I would probably go ahead and distribute this thing. So if we're doing 2 times x minus 1 is 2x minus 2 on top. The other one looks like 1 over x times x plus 1, x minus 1. I got to multiply this by something, and the thing that I want on the bottom is x times x plus 1 squared, x minus 1. And if I'm looking along here, I have my x here. I have an x plus 1. I need to make it an x plus 1 squared. So I need one more x plus 1. My x minus 1 is there. And if I'm looking at this, this is an x plus 1 times 1 is an x plus 1. Okay, so I have this thing. Let me write this thing down. X minus 1 here. This thing is subtraction this time, so x plus 1 squared, x minus 1. I got it over my common denominator. The first thing looks like 2x minus 2. The next thing looks like x plus 1. So I have to do the subtraction correctly. So you do have to do some distribution. Don't miss the distribution. But I'm writing out my common denominator is that crazy thing, x times x plus 1 squared and an x minus 1. On the top, I have 2x minus 2, subtract x, and I'm going to subtract 1. I have to combine some like terms now. 2x minus x is going to give me x. I have a minus 2 and a minus 1 is going to give me minus 3. I have an x. I have an x plus 1 squared, and I have an x minus 1. So we're looking along here. We've just done the subtraction. We combine like terms. And I'm looking if I can simplify this thing. It all has a factor of an x minus 3. So you might notice there's no other x minus 3 down here. There's no x on top. There's no x plus 1 on top, and there's no x minus 1 on top. I think this thing should be fully simplified. All the factors are different. Okay. So with this said, I know I set it up like and did a lot of work to get a common denominator. If you do enough of these, you might start noticing like an easier way to sort of look at this. If it makes sense to you, good. If not, I don't know. Maybe do it the long way, right? If you're having difficulty with it. but this is x and an x plus 1 squared. What does this thing have but this thing does not? What is it missing? It's missing an x minus 1. So I know I'm doing an x minus 1 on this thing. And now I have an x and an x minus 1. What does this thing have that this thing is missing? It's got an extra x plus 1 because it's got an x plus 1 squared. So maybe if you get good enough at these, you can start doing something like that. But it will definitely take a lot of practice. This one might be a little easier to do it on. So now we have a student activity, and they just kind of throw it at you, right? 3z over z squared minus 9 minus 2 over z minus 3. They don't tell you to do it. What should you really do to start this thing out? Should be looking right here, and I need to know what my common denominator of these things is. So z squared minus 9 is really z plus 3, z minus 3. And I have another one that looks like z minus 3. If I want to find the least common multiple between these two things, it's both of the things together, z plus 3, z minus 3. There we go. This is my least common multiple. Three z over z squared minus 9 looks like z plus 3. What it ended up with, it's already in my common denominator. I don't need to do anything to this. The other thing looks like 2 over z, what, minus 3? What is this thing missing? It's missing the z plus 3. All right, so I'm doing 2z plus 6. If I do that distribution, is 2 times z plus 3. And now I'm doing this one minus that one. 3z over z plus 3 minus 3. And minus 2z plus 6 over the same thing. And now, gotta do that subtraction correctly. This is 3z minus 2z. Schematic, you're gonna do minus 6 as well. We're gonna do z plus 3, z minus 3. Three z minus 2z gives me a single z. I believe on top I'm getting something like z minus 6 over z plus 3, z minus 3. I'm going to drop my equal sign somewhere along the way. These are all equivalent expressions. And we got a simplified expression, z minus 6. It might be hard to try to factor that, but this is z plus 3, z minus 3. It's like, oh man, 6 is a multiple of 3, but nope. Can't find a way to factor that. Those are all different factors. That is fully simplified. All right, we got one more page of practice. So we have the approach down. Oh man, the last problem, I feel like the last problem might even be the easiest problem on this entire lesson. This one, I think, is probably the pinnacle of the lesson right here. So you should be able to do these things by now. So again, if we look at these and they are not factored, what is the first thing we want to do to find the common denominator? We want to factor these things. these things, they are starting with the 1, so we just got to find the magic numbers. What multiplies to 10 and adds to -7? 5 and 2 will make 10, and I got to figure out the negatives. I think they're both negative. So y minus 5 is this one. This one, I believe we're getting what? 5 and 3 will multiply to 15 and add to -8, both being negative. Y minus 3, y minus 5. And so if I'm looking here and I want to find the least common multiple between, I guess I'm going to rewrite this in another order, but I got to keep one of all 3 of these, right? Basically, I'm combining all 3 of these factors. Again, this one might be an easy one to sort of look at and like, what does this one have that this one's missing, and what does this one have that this one's missing, right? And we're going to kind of multiply by that. But I will do it out the long way just so you can see it. If I have a 3y, and now I want to put this in the factored form of y minus 2, y minus 5, and now I want to multiply by something and end up with y minus 2, y minus 5, y minus 3. The thing that I'm going to have to multiply by is the y minus 3 on top and bottom. All right, if I do that, I'm going to go ahead and do the distribution. 3y times y minus 3 is going to give me a 3y squared. 3y minus 3 is going to give me minus 9y. Ooh, okay. Now we get a 2y. And this one I factored it was y minus 3, y minus 5. Anyone multiplies by something, I'm going to end up with the same thing on the bottom, all 3 of these factors. The thing that this one is missing, that the other one had, was that y minus 2. So we want to multiply by y minus 2 on top and bottom. 2y times y minus 2 gives me what? 2y squared. And now I'm looking at this thing over this thing minus this thing. And I got a 3y squared minus 9y. I'm going to go ahead and just combine it over the common denominator, minus 2y squared minus 4y. And again, I do have to do some distribution with that second one, so I'm going to put it in parentheses. All over that crazy common denominator that I found. All right, so we get this thing combined in like terms. 3y squared, and I'm going to subtract 2y squared is going to give me a single y squared. I get a minus 9y. Now this is going to become plus 4. Minus 9 plus 4 is going to give me minus 5y. So that top is giving me y squared minus 5y. The bottom is giving me a y minus 2, y minus 5, and a y minus 2. All right, so now I'm looking at this thing along this thing. I see a y squared minus 5y. I have combined like terms. I have subtracted the thing. I've combined its like terms. Now the last thing after I do addition and subtraction of fractions is I need to make sure they are fully simplified. This thing is fully factored. This thing, I need to do a little bit of factoring, but they got a common multiple.
before the y, I have y minus 5, I have y minus 2, I have y minus 5, and I have y minus 3 as well.
All right, so you might notice they do have a common factor. There we go. Pull out your machete, chop them things up.
We got a y on top, a y minus 2, and a y minus 3 on bottom.
And I dropped my equal sign somewhere along the way, but these are equivalent expressions. We look at this, we see a y. That's different from a y minus 2 or a y minus 3. All right. And the last problem we're going to do, this, I think they're just trying to test your knowledge a little bit. It's like we got an x minus 8x minus 4 over 5x plus 2 minus 6. And we did this last time when we added and subtracted, or multiplied in last section when we multiplied and divide. Now we're adding, subtracting. It's the same concept. If I see it and it's a whole number or it's something that doesn't have a denominator, I can always put a denominator of 1 there. All right. And if I want the least common multiple between, what, 5x plus 2 and 1, guess what it's going to be? It's going to be 5x plus 2. So we need to convert this 6 over 1. 5x plus 2. What do we multiply 1 by to get to 5x plus 2? Oh, man. Guess it. It's going to be 5x plus 2. So I'm doing 6 times 5x plus 2. I'm doing 30x plus 12. So I have an 8x minus 4 over 5x plus 2. And I want to subtract this thing. 30x plus 12 over 5x plus 2. And so I do something like 8x minus 4. I'm going to subtract 30x, and I'm going to subtract 12. So you do have to do some distribution here. I'm going to go ahead and do it in this step. $8x minus 30 is going to give you what? Minus 22x. A minus 4 and minus 12 is a minus 16 over 5x plus 2. And if you can see a way to simplify that, you're doing better than I am, because I don't think there's any way that this is going to have anything in common with that. All right, so that's the last problem. I will see y'all soon. Take care. Study hard.